Hello, hello, and welcome everybody. We are episode 3 today, and returning again is Marc. You want to introduce yourself again?
Yeah, sure. Thanks, Pierre. So my name is Marc Borstein, CTO at TremoloSecurity, open source identity management, authentication, authorization, which we'll be chatting about today.
Cool. Akansha?
Hey everyone, so I'm currently working as a developer relations at EmpathyOps, so I'm pretty new to this field and learning on the go. Yeah.
Thanks for that. And then I'm Peter O'Neill. I'm taking over for Marino today. I am a cloud native architect at a consultant firm called WebRight. And yeah, today we're going to be diving into a little bit more authentication and authorization with Marc and Tremolo. So with that, let's start to kick things off. Marc, where do you want us to start here?
So we've kind of had this story building over the last couple of episodes, right? We started off with deploying our cluster, getting authentication built into the cluster. We used Istio. We're going to use Istio for ingress, right? We're using that for ingress, but Istio's got a lot of application level capabilities around security, right? It's got authentication, can validate a JOT. It can do some authorization as well. So today I thought it'd be a lot of fun to say, okay, let's move out of Kubernetes. Like, we've got our cluster up and running, but let's deploy something. Like, let's actually see a web service run, walk through how that web service works, integrates with Istio, uses the Istio built-in capabilities for authentication and authorization, and just kind of see that whole life cycle play out.
That sounds great to me. And let me just kind of recap my notes here since I'm taking over from Marino. So what I see so far, we have a Civo cluster running in London 1. We've installed Open Unison, OUCTL, and the dashboard on our machines. We've configured Okta to be our identity provider that hooks into Open Unison. And we are, let's see here, and then, so yeah, we've created the certificates inside of the cluster for Istio so that everything is set up to be trusted. I've trusted that certificate on my own machine, so we can use that now. And then it looks like last episode, you guys got Cert Manager installed and started working on that PKI infrastructure. Does that sound like I captured what we've done in the last couple episodes, like in a nutshell? Am I missing anything big or important that you guys remember?
Nope, that sounds about right to me.
All right, great. That's awesome. So I think we're at the same page here. Let's start to kick things off. You want me to share my screen?
Yeah, that'd be a great place to start. And why don't you go ahead and log into the cluster using Open Unison?
Okay, let's see. Don't show. I'm gonna share the screen. Cool. I kind of got a split screen here. I have my Okta on the right. Log in with my 1Pass. This is pulling up our Open Unison dashboard that we just talked about that got configured. And now you want me to pull one of these tokens, I imagine.
Yep. So go ahead and click on Kubernetes tokens. And then click on the little box next to kube control command.
Sweet. Yeah, let me see here. And then what was that? There was an export command that you wanted me
to. Let me paste it in.
Right
so
here,
So I like to... the nice thing about Open Unison when you're working with your clusters, you don't have to manage the files. They just, they're disposable at that point. So now you should be able to get into your cluster.
Cool. Yeah, I like this. So so just the chain of commands here, and then we can see at the bottom here, the cluster was set, context was set. And so, all right, let's do, I like to do kget nodes to see what I'm working with. So we got a couple K3S nodes, sweet, and that London 1 resource. All right, this looks good. With that, we are authenticated. What's next?
So let's go ahead and deploy a web service. So I took the examples from Kubernetes and Enterprise Guide, 2nd edition. I'll show it off over here. We actually just announced the 3rd edition is going to be published in August. If anybody wants to get an e-copy of the 2nd edition, I'll tell you right now, skip Amazon, go straight to Packet. It's like $10 from Packet. Don't spend your hard-earned money on a Kindle version. And there's no DRM. So we have 2 chapters on Istio in the book. The first chapter is like just getting it up and running. We're past that point, obviously. In the second chapter, we actually talk about using Istio kind of as a web application gateway or more of an API gateway is the word I'm looking for. We talk a lot about Istio as a mesh, free certificates. You get identity from those certificates. You get some built-in security. But what a lot of people don't realize is Istio's got a lot of web application gateway features in there. So when I talk about web application gateway, when folks talk about mesh, they're often talking about east-west. I've got services inside of a cluster that need to talk to other services inside the cluster, right? And that just works, right? That just magically works. You configure it. It works beautifully. But when you talk about API gateway type functionality, you're often talking about what's called north-south. So instead of talking within your cluster, you're talking to APIs that might be running anywhere, right? So to kind of show that off, what we've got is a API. It's built on Python, very simple, right? We're going to deploy that API into Istio, and we're going to see how that works. Then we're going to go ahead and say, well, I want Istio to require a JWT, a JSON Web Token, in order to use it. We'll see that works, or we'll see that that's now being enforced. But now, where do you get your JSON Web Token from? So we've got a simple app that will log into OpenUnison using OpenID Connect, and then get a JSON Web Token on your behalf, and call the web service. So we'll look at all the different authorization layers in there and how that all gets configured. So I sent you a gist, Peter, and I guess if folks want to follow along, we can post.
Yeah, speaking of folks, I see a couple people have popped in. I see Rahul. Thanks for joining. Siddhant, I think I saw your name on the last one. Thank you for joining. And yeah, so Marino just posted that gist in there.
Yep.
Krish, good to see you. All right. So yeah, let's kick things off. I have that just on my machine.
Yep. So if we want to start with OpenUnison-istio.yaml, let's kind of walk through what's going on there, because it's Kubernetes, so we got to have a lot of manifests. So the first thing we're going to do is we're going to create a namespace. No big deal, right? We're going to create a config map. So this config map is actually going to be our web service. It's going to be our source code, and it's going to be how we launch it. Kids don't do this at home. And the web service itself is very simple. We've got a few, really two different web services that we care about. If you go to the /, the root, that's just going to echo back some data about, the service. And then the who am I service, this is where things will get really interesting, is it's going to take the information from our JOT header, our authorization header, and we'll look at what that looks like. And just echo it back, just to show, hey, authentication's working. It's actually doing something with the user information.
Cool, that makes sense. And like Flask really brings me back to like some of the very first things that I programmed, and just having that just very simple web service, and you just get that information back and forth. So I mean, as a demo, this seems like a very simple way for us to just interact with what's going on inside of the cluster.
Yep, and notice that other than pulling in the information, there's no authentication or authorization code. We're not validating the JOT. We're not, if group equals whatever, everything's being handled by Istio. So our next object is a deployment. Nothing really super special there. It's just a deployment. It takes our scripts from the config map, runs them. We then have a service to bind to a virtual IP inside our cluster. And now let's get to the Istio part. So there are two objects, right, that you need for any service to be exposed. You need the virtual service and you need the gateway. So first we define our gateway. And, we've got a host name. We're going to use the same nip.io trick that we did with OpenUnison. So if you didn't join us for the last live stream, we're using a service called nip.io, where if you do not have an active DNS service, put the IP inside of the host name, and it returns back that IP. So it's a very convenient way to do DNS without doing DNS. Just note that it is a public internet service, so you're sending IP information up there, and a lot of corporate networks actually don't allow it because, unfortunately, we can't have nice things, and the folks that write malware also like to use it. But for stuff like this, it's great. So we define our gateway. We say, look, we're using simple credentials, so we're telling Istio, hey, don't worry about mutual TLS, just simple TLS authentication. Then we've got our virtual service. Virtual service, again, is routing. Now, this is also where you'll see our first layer of authorization, where there is a CORS policy. So CORS, and for the life of me, I can't remember what CORS stands for.
It's like cross-origin resource something.
Resource, yeah, you got it.
Yeah.
So everything in web browsers today is done by JavaScript, right? And because of the way that cookie rules work, if I'm logged into my Capital One, or I'm logged into my Capital One account, and then I go to a malicious website, and it opens up JavaScript to Capital One and takes all my money, right? So browsers help protect against that by implementing this thing called CORS, where sites have to explicitly say if you're going across domains, it has to be allowed. And if it's not allowed, it's not, like, the website's not even going to bother. And so here's our first layer of authorization, where we're saying our virtual service will be accessible from any JavaScript that comes from app.ip.nip.io. And that's because that's where we're eventually going to be running our web application. Now, this is enforced at the browser. This isn't enforced at the server. So once we actually deploy this, you'll find that we can do a curl command and hit our service just fine. And then finally, we have a certificate. So that way, all's good when we're trying to access the site. We went through the joy of setting up Cert Manager last time. This was a big reason for that. Now we don't have to worry about certificates. It's all good to go. So if you want to grab the raw version of that and do a kube control apply, we should be able to get this party started.
Cool. Let's do it. All right. Copy that. Drop it into my terminal here. Yeah, that looks good. Oh, no, it didn't. Something it didn't like.
Just do, if you do kube control apply -F and then the gist URL, the raw gist URL, that'll work too.
Yeah, that sounds great.
Usual disclaimer, don't run things from the internet at home.
All right, that looks good. These look like each of the services we talked about here.
Yep.
Namespace, config, deployment service, gateway, virtual service, and certificate. All right, so that looks good. We have our app is probably spinning up. Let's do a get pods. And what's that namespace?
Istio Hello World.
Copy that.
All right. So now let's give this a go. So if you do curl HTTPS, whatever that host name was in the virtual service, I think it's service.ip.
This thing right
about
here?
4 lines up. Yep, that'll work too. And we got a hello world, right? So our web service works, right? We can call this web service. It doesn't really do anything super useful, but we can see that it's actually doing something. It's got the host in there, and it's not just a print line.
Mm-hmm.
So we're talking about authorization, right? Before you can authorize something, you got to know who it is, which means you need authentication. And so the way Istio does this is really one of two ways, right? Out of the box certificates, right? Mutual TLS. East-West mutual TLS is great. Works beautifully. It works right out of the box. You can tell Istio, hey, I'm going to allow some services to talk to each other while other services not to. And it all just it's magic, right? It all just works through the magic of PKI and PKI and policy. And as an app developer, you don't need to know anything about MTLS, right? You just open up a connection, you're good to go. But when you're talking about north-south, MTLS has a scalability problem. And when I say scalability, I don't mean like a performance scalability. I mean a network scalability problem. Because chances are when you go north-south, you're going to go through multiple TLS termination endpoints. You're going to have a load balancer. That load balancer might be what's hosting your certificate. A lot of enterprises, that's true. You might then have, your ingress might be a TLS termination endpoint. So, there are multiple places where that TLS connection could break. And the security you get out of MTLS, a lot of that goes away once you lose that TLS termination endpoint, because now you have to transition to something else, right? Mm-hmm. Like you either have to inject a header, maybe you generate a new JOT. Anybody that was around back in the Windows days with 3-tier applications and Kerberos, you'd have protocol transitions and stuff like that. So once you break through that TLS termination endpoint, you lose a lot of the security that MTLS gives you. So that's where JWTs, JSON Web Tokens, become really powerful. And in fact, you're using a JSON Web Token now when you work with Kubernetes, right? You're logged into OpenUnison. OpenUnison generates a JWT for you. That JWT is then sent to the Kubo IDC proxy. JWT.io.
Great resource. Like if you're ever working with these tokens, being able to like drop them in here and kind of just like see what's inside of it, so you don't have to actually do the base 64 encrypt. When I first found out about this tool, I was like, oh, this is saving me so much time. And so if you haven't seen or you haven't worked with JWTs before, this is a great way to like experiment and play with them.
And in fact, we're going to play with this tool as well. Now, something I want to point out, there's a big banner at the top. JWT.io, everything's done in your browser. Nothing gets sent back. But be very, very careful whenever something says just drop your token in here, because these are what are called bearer tokens. Okay. It's like, pick your favorite sports ball, right? Like I'm a big baseball fan. I get my ticket. My ticket doesn't have my, nowadays it does, but once upon a time, your ticket didn't have your name on it, right? You picked it up at the box office, and if somebody stole it out of your hands and ran up, you were screwed. Like that was it. Mm-hmm. Okay. JWT is the same way. Everything in the JWT is enough to get in. It's self-contained, and it's not bound to anything. So if you give somebody your JWT, they can use it. Mm-hmm. So you always have to be very mindful of that. And in fact, I think we talked about this in the Twitter space last week. Okta and Cloudflare just had another reported breach where they were using an old JWT that was stolen from the original Okta, breach back in November or October. So you want to be very careful about JWTs. So whenever you get a site that says paste in your JWT, just make sure, JWT.io, I think it was created by the folks at AuthZ. Yeah, AuthZ, maintained now by Okta. They know not to, publish it or to you could run this with no internet connection. It would work just fine. So that said, how do we now add this onto our web service? Mm-hmm. So if we go ahead and look at the Istio-auth, Istio-auth, there are two objects that we're going to create. So the first object we're going to create is a request authorization. So this tells Istio how to request authentication rather. This tells Istio how to validate the JWTs. Now we have the issuer, and you'll see that we've got two configurations. One's commented out. One is JWK URI. The other is JWKS. Because we have a self-signed certificate as our CA, you would have to configure Istio to trust it, which is doable via the operator, but I didn't want to mess with that, so we cheated a little bit. And we included the actual JWKS, which is the public key used to validate JOTs coming from Open Unison. So in real world, you'd want to make sure to hit the actual JWKS URI, because that way, one of the beauties of OpenID Connect and using JOTs is that nothing is static. So if you have an issue and you want to rotate your keys, and like I want to say, is it Google? There's a couple of different OIDC providers that are like, we rotate keys every couple of hours or every day. And so by rotating those keys very often, it's ephemeral. And so it's just another way to protect against token reuse. So if you're going directly to the URL that hosts it, if something fails validation, you say, okay, well, I'm just going to go check to see if there are new keys. And if there are new keys, then you're good to go. And that trust is established because you already have a trust established because you're trusting the enterprise CA. So you're using multiple layers of trust in order to build a more dynamic environment, one that you don't have to worry about statically moving keys. If you don't have to worry about statically moving keys, you can feel comfortable rotating them more often. So that's the first thing. And then the last two configuration options in that object, you've got the audience and you've got the output payload header. So the audience, every JWT that gets created has, or it's supposed to have a claim. A claim is an attribute inside the JWT called the audience. And it says, this is the only person who should accept this. And so that audience becomes really important because you should only be accepting tokens that you're expecting to accept. You don't want to accept tokens from another provider or even another that are meant for another system, because they just might not be set up the right way for you. So another layer of authorization built into the system. And then the second object here we have is the authorization policy. So this tells Istio how to authorize the request. And what we're saying here is that for our run service, we want to make sure that you have a principal. So you'll see at the bottom, from source, request principals. That just means there is a JWT that matches with our authentication policy. We don't really care what's in the JWT right now. But yeah, we want to say these are authenticated, and we want to make sure that they're coming from, in this case, Open Unison. So this is where we can go ahead. Let's go ahead and run this particular one.
Cool. I have one question before we do. So with this audience, my app, where is this defined who my app is? Is this something that we're going to define later? Is that?
Yeah. So when we create the trust between our demo application that's going to use this web service and Open Unison, that's when we're going to define my app.
Okay, cool. That makes sense to me. All right. Yeah, I think I'm all caught up on that. Let's look at the raw. And so same thing, kubectl apply -f for this.
Yep.
Just grab I'm gonna grab the URL again because that was easier. That looks good.
All right, so now run that curl command we tried a few minutes ago again. All right, give it another few seconds. Takes a minute for Istio to catch up. All right, try again. See? Access is now denied. So what that means is now our Istio service mesh has applied a requirement on top of our web service that says you have to be authenticated. You have to have a JOT that we can validate.
Right. And so inside of that JOT is all of this information here, all the certificate information, like the common name, the organizational units, and so this is all the information that Istio is looking for inside of that JOT token?
No, all that is the public key.
Oh,
so,
okay.
So if you look at that, really all that is it's a key that we in Open Unison maintain for you.
Mm-hmm.
And it's just the public key. So something that's really important to understand the difference between OpenID Connect and MTLS and SAML, if you've had to work with it, is OpenID Connect does not work with certificates. You can if you really want to, but it really works with just the public key. So in the PKI world, you have just two really big numbers, a private key and a public key, right? But there's no metadata. Like there's no information about it. When we talk about a certificate, things like the subject you had mentioned, the subject alternative name, the issuer, validity dates, those are all additional information that's integrated into a certificate, but really has nothing to do with PKI. Like it has nothing to do with encryption and decryption. That information is all there so that the two parties talking to each other can authorize each other based on a certain set of rules. Like, oh, I'm going to trust this because this certificate, this information was digitally signed, which just means encrypted, with the private key of the certificate authority. So all that metadata information that you get in a certificate is not leveraged in this scenario.
Okay. And then so I guess we're getting all of the IDP configuration from this issuer URL here. We're hitting this, and this is how it's saying what we're looking for in that JWT in order to give me this access denied.
Exactly.
Got it.
So OpenID Connect uses what's called the OIDC discovery format, where it provides all the different URLs to be able to hit. One of them is the certs URL, which gives you the public key information. So if we were hitting that URL directly instead of embedding the key information directly into the YAML, what would happen is, let's say you wanted to rekey by deleting the secret inside of OpenUnison, telling OpenUnison, okay, go ahead, redeploy with the new signature key, your services would just keep marching on.
Okay.
They wouldn't have to reload that. You wouldn't have to go to each individual service and say, hey, go reload this key. So, anyone who's ever worked with SAML knows that once a year, you've got to go to all your different service providers and say, okay, it's time for me to rotate my cert because nobody's pulling that information in automatically. It's beyond painful. Whereas in OIDC, if you're using OIDC discovery, nothing is static. It's all dynamic. And the trust is built on the layers of TLS that are used to get that information rather than statically setting it.
Cool, that makes sense. If I drop this URL into the browser, will it just show me that config?
No, but what you can do is, let me make sure I got this. Curl. Yes. So if you take that particular URL, which is what's called the issuer, I'm going to drop this into the comments, and you add .well-known/OpenID configuration. So that uses a standard nomenclature called WebFinger. That will, there you go, load up the OIDC discovery document. And this is a standard. So you put the issuer in there, and you'll see that the issuer, this is, so in JSON world and in JOT world, the attributes are called claims. So there's an issuer that lines up with the issuer that was in our authentication request document. Those things have to line up. Then you've got the different endpoints, but the one that's really important for us is right now is JWKS_URI. So if you pull that, like if you take that URL and drop it in your browser, that's the information that was in that authentication request.
Yeah, we passed it in with this line. I got you.
Exactly. So if we had our certificate trusted by Envoy, which is what's doing all, or not Envoy, Pilot, which is what's doing all of this work, we would uncomment that JWKS URI instead, and that would pull in that information dynamically.
Cool. All right, that sounds good. So we have this. We have our authentication and our policy all configured now. We know that it works. What's next?
So the next thing we need to do is go to, which file is it? I had this broken up in an order and just reorganized it to make everything in alphabetical order. So now I'm all out of sorts. Okay, so there's a gist called Istio-app. I think it's the first one.
App. Okay, yeah, first one.
Okay, so you asked about where we defined my app.
Yep.
This is where we define it. So this trust object is an open unison object, and it's what defines a trust in OpenID Connect. So from this standpoint, we're going to just piggyback off of the same identity provider that we use for Kubernetes. In the real world, you probably wouldn't want to do that. You'd want to configure your own, but we're just going to keep it a little simpler. So we're going to use the same identity provider that we use for Kubernetes, which means we're also using Okta. We don't have to create a new trust up to our enterprise identity provider.
Mm-hmm.
So what's going on here that's kind of important is you've got highlighted the client ID as my app. So once we deploy our actual application, which we'll do here, that will go ahead and what we're doing is we're establishing a trust between Open Unison and our application, our web application, which is what we'll see log into. We've got a couple of interesting timeouts here. So like there's an access time to live. That's 120,000 milliseconds, 120 seconds, 2 minutes. So 2 minutes, that's how long that token is good for. Now, what can you do in 2 minutes? Well, if you know what you're doing, a lot, but if you're just clicking around a web application, not a whole heck of a lot. So then there is a refresh token timeout, which is not defined here. It's defined in the main body of the identity provider. Mm-hmm. And what's important about that is when we go ahead and log into our test app, the only token that goes between our test app and our web service is our ID token. That's our bearer token. The refresh token, that's the thing that we use to keep that token up to date, is good for 20 minutes or maybe 15. I forget off the top of my head. But the point is that particular token only goes between Open Unison and our web app. So if there is a bug anywhere in our implementation between our browser and our web service, like a logging bug, someone accidentally logs a token. I think Calico had that bug a few years ago where they were logging tokens. This will help protect you against that because by the time you lose that token and somebody knows what to do with it, it's already expired. And your web app is going to keep your token up to date. So just like you've been messing around inside of KubeControl, you haven't had to refresh anything, right? Like you haven't had to log back in. That's because KubeControl is keeping your token up to date with Open Unison. The web app's going to do the same thing. It'll be constantly refreshing the token.
Does it do that when I use it, or is it consistently doing that in the background for me? Like, is it only going to happen when I'm interacting with it? So if I don't use it for an hour, then it's gone? Or how exactly does it refresh it?
That's a great question. So KubeControl does it when you use it. So if you walked away for 20 minutes and came back, the token wouldn't work anymore. The refresh token would fail. Mm-hmm. Web apps get a little bit more difficult, though, because web apps will have a background thread that are constantly refreshing the token. We'll see that when we log in, which, of course, makes it a little problematic because you want to have an idle timeout. If I'm not touching it for 15 minutes, it should sign out. So you should have something in place. So like if you click on your tab for Open Unison Scale, that first tab. Okay. So it actually hasn't. Oh, you know why? Because you're constantly using it. So Open Unison is constantly doing a session check to make sure that your session is still valid. Because you keep using KubeControl, that keeps both sessions alive.
Oh, interesting. They're intertwined. So it knows
they are intertwined.
My user ID, identity or something. And so it says that these two things are the same session.
Yep. Cool. And in fact, what I'll show you is when we get to the end and we want to force a log out, you delete your OIDC sessions in the API server, and that's going to log you out of everything.
Cool. That makes sense. I was wondering because I had this open before we hopped in the live stream, and after a couple minutes, it would just be like, "Yeah, no, you're not here. Goodbye."
Exactly. So the way that we set that up in Open Unison is we actually have a separate API called Session Check that is constantly, every minute saying, hey, is this session still good? Is this session still good? Oh, you've only got 5 minutes left. Do something or you're going to lose your session. And that's the common security practice. You want to have something that's checking to make sure that you're actually doing something versus, just waiting for a token to time out, because you're going to have that background thread constantly updating the token so that you don't have a long-lived token living in your browser.
Right. So that might be a good reason to have like both the browser and your terminal open, because the terminal is not going to give you that prompt, but the browser would.
Exactly. So if we go back to our gist, so we established the trust. That tells Open Unison allow SSO, like create SSO. Now, so no keys that are being exchanged here. There are no certificates. That's because everything's dynamic. You don't have to do an explicit certificate exchange in order for the OpenID Connect to work properly. So the rest of this stuff is actually pretty straightforward. You've got a certificate, so that way our web app will just work in the browser. You've got a namespace. You've got a deployment. This deployment is a very simple React.js web application. It is ugly as sin, but it works. Then we're going to use that to show the actual login process. And it uses a library, I think it's called OIDC React, that lets you do all this OpenID Connect stuff without actually having to know how it works. Like, it just works magically for you. And then, and that's just running inside of an Nginx container, to host the HTML, because it's all client side. Then the rest of it is just networking plumbing. So we have a service. Again, we have another gateway and a virtual service to be able to make everything work. So at this point, we can go ahead and launch this YAML, because it wouldn't be Kubernetes without YAML.
Cool. Let's do it. So back to the raw. Grab this URL again. kubectl apply-f. Sweet. All right. No errors there. Should I check on the deployment or anything?
Yeah, why don't we go ahead and look to see that the deployment's there.
What namespace is this Istio app? There we go.
Yeah, Istio-app.
Okay, get pods. All right, that's
all right. So we're up and running. So now go ahead and in the new browser tab, go to the URL in your virtual service. Yep.
This one? Okay, cool. Does that look right? App.
That does look right. App dot. Hit it again. Maybe it just needed a second.
Should I drop the HTTPS? Is that a problem?
No, that shouldn't be an issue.
I didn't change anything.
Let's see here. Got the virtual service. Deployment.
Yeah.
Okay.
Service.
Gateway. Go back to the other tab where it was angry. Click on the certificate. Let's just double check that. So that's complaining about the certificate. Click on site settings. Oh. Are you in Firefox or are you in Safari?
This is Brave. I could try Safari.
Should work. Oh, there we go. Weird.
Yeah, so it must be a Brave setting, because Safari is much more tightly integrated with my keychain where I've installed these certificates.
So we click login. Now, what you didn't see, because it went by so quickly, is you went through Open Unison. So this is a double hop. You got redirected to Open Unison. Open Unison said who you are, and now you're going to authenticate to get into the app. Now you're going to bounce back to Open Unison and bounce in. Now, interesting. Not log in.
Yeah. What does that mean?
That should have worked, actually.
But it also says log out at the bottom, which is kind of
right. So we have a token, but it should have just authenticated. Does Safari have developer tools? I actually don't work in Safari all that often.
I believe so. Let's see here. I haven't used it in a long time, though. If anyone watching knows how to get to these developer tools, definitely shout it out.
Try going back to Brave, just out of curiosity.
Cool.
Yeah, that's weird. It doesn't...
Yeah, it's weird that it's calling it a 404 when it just worked on the other one, so it's definitely...
Yeah, I wonder if it's a routing thing.
Oh, do you think if I like clear my cache?
No, I wouldn't query your cache. It's just
I could also turn
usually,
off Brave settings and maybe that'll do something. No, didn't do anything.
No, that's weird. All right, well, let's go back to Safari. Let's see if I can fire Safari here. So if you go to, there should be a develop menu bar
on Safari.
Yeah, like you got to enable that. If it's
Okay, so in Safari.
So
preference.
View. Show.
Is there any advanced tab?
That's what I'm trying to figure out. Did I have to do something to enable developer tools? Safari.
Okay, let's see here.
Enable developer.
To enable that, you will need to go to like Safari menu and then preferences, and then there's a checkbox.
All right. Sorry, you're a little quiet, Akansha. Can you said Safari menu and then what?
Preferences.
Preferences.
And then there's a checkbox.
Go to settings, I think.
Settings. Advanced.
Yeah, there's a checkbox. There should be a checkbox.
Privacy.
All the way at the bottom. Show
there
features.
Yeah.
There we go. All right. So now you've got that develop window or that develop menu up at the top. You can close this.
Okay.
And then up at the top in the menu bar, there's develop. Yep. And you're going to want to go to show web inspector, I think.
Then there should be developer console. We will have to go to develop and then show JavaScript console. Oh, it's
right. Cannot load due to access control checks. Status code. Okay, so pre-flight response is not successful. Interesting.
And so this public IP here, this is the one that's assigned to the CVO cluster that we have. Is that where this is coming from?
Yep. My guess is that we need to tweak our authorization. We're looking where we're looking at Istio auth. So we're going to do no, not Istio auth. We're going to be looking at the service.
Yeah, because that app dot should be our front end, and that service dot should be the back end that actually translates it into something useful.
Yeah, it's okay. It's a virtual service for the service one, and we need, it's got service gateway.
The other virtual service.
Get options, allow headers authorization, HTTPS app.74.220. I'm looking at the allow origins. 220.18.48 nip.io. Yeah, looks right. Well, allow methods, get options. Go back to your developer tools in Safari.
should we try log out, log back in, and see if that gives us more information in this console?
No, I don't think that's going to get us anywhere. We need to access control checks. App dot 74220. Just out of curiosity, do you have just generic Chrome on this box?
Yeah, looks like.
Give that a try. That's why I was doing my testing in.
Where'd it pop up? Oh, there it is. Okay. This. Should I update it? I don't know. Maybe we'll just leave it at this for now.
Probably fine.
Yeah.
So that's good.
Should we open this inspect real quick just in case?
Yeah, it's not
Log
a
in.
terrible idea.
Connecting. Let's drop my password in here. What happened? Autofill. Ah, jeez. Okay. We'll copy. Not logged in.
We're having the same problem.
Yeah. So it's definitely cluster side.
From origin has been blocked by core policy.
Yeah, let's make this bigger for you guys.
Response pre-flight request.
Of course.
No access control allow origin is present.
Okay, so it's course policy.
Yeah, it's complaining about. So the first one tells us what the problem is.
Yeah.
That has been blocked by course policy. So click on, in the developers tool, see where it says console sources? There's a double arrow next to that. Network at the top. All right, so the first one, click on that. So click on response headers. If you look up, or nope, go back to headers. And then in the middle, yeah. Oh, there are no response headers.
Yes.
Interesting.
That is weird.
Oh my.
Why are there no response?
It says that this error comes in that when we try to access a web application on a different domain from, which is different from what it originated from.
And we should have. I remember setting the cores policy in here.
Yeah.
So,
Actually, go back to go back to Chrome. Click on. See how there's a second "Who am I" under the one? Yeah. Click on that. Here.
this one has response headers.
Yes.
Yeah. So that's got, and so 404 not found.
Yeah.
Why are we getting a not found from Istio? So request method is options.
Right. So our IP address is right because we're at least getting a 404 from it.
Yeah.
It's just something inside, or whatever it's looking for inside of the service is not showing up.
Right. And the response should include the course headers. And the fact that it doesn't is a little weird. Let me think about this. Let's look at our.
Because it's like this token is returning a 200 OK, and then after that it's failing.
Yeah, my guess is right. So token works. So click on token.
Yeah, this is the 200.
And then look at the response headers.
Yeah, we've got 11 response headers here.
Right. And then we also have, see how it has access control, allow, access control origin. So we've got it set up to be wide open here just to make life a little easier.
Yeah.
The only thing I can think of is that if Flask is returning a 404, I wonder.
Can I grab the logs from that Flask container? Is that?
Actually, look at the application gateway. in the Istio system namespace. I would start there.
Okay, you said the application
Or the
gateway,
service
this one.
gateway, rather.
All right, so it's in that namespace. So if we do k get gateway in Istio app.
No, I'm sorry. Look at the pods in the Istio-system namespace, because that's where the actual gateway is, or virtual gateway. So yeah, so look at the Istio-ingress gateway, the second one.
Okay, you want me to look at the logs or?
Yeah.
Logs. Lots of stuff.
Oh.
Yeah, so the last one that came through was post. Yeah, you can see the scale session check. Do a okay, options, who am I? No route found.
Wait, you were saying you want me to run that again with the grep?
Don't even look at the second to top line. It says options / who am I? Route not found. Do we have to have a separate route for options versus get in our?
Oh, in Flask?
No, in I bet you that's what we need to do. In our virtual service for the service. So if we take a look, edit the virtual service called service-vs in the Istio Hello World namespace.
Cool. So I'll just grab the raw, open it up in a local text file. Is that best way?
No, that's not right. Because there is no route. Istio is saying there's no options route, but we don't have anything that's limiting methods. Istio options 404. Route not found. Ajax call. So we did that.
Could it be due to any like firewall or a proxy that is like blocking the request?
I don't know, but let's take a look. So let's take a look at the let's take a look at the Flask. I think it's Istio that's blocking it. I don't think it's Python, but let's take a look.
Okay.
If we go to the pod in the was it the service namespace? I forget what I
this
called
one right
it.
here, this deployment run service.
Yeah, let's look at the pod from that.
Okay. All 200s. Interesting.
Yeah, well, and it's just the health check. It's not even making it to.
Well, so one thing. Yeah, you're
Yeah.
right. It's all just health check stuff.
It's all just health check. It's not even making it to who am I. Do this. Run our curl command, and then do slash who dash am dash I. Okay. Now, after the curl, do dash capital X options all uppercase, and then do dash V so we can see the headers.
Capital V doesn't matter.
Lowercase v.
Okay.
All right, so we got a 403, which is what I would expect. That's interesting. So Istio is definitely blocking it. But the question is, why? Well, it's the same reason. You know what? Let's try this. Delete all the pods in the istio-system namespace.
Okay. Okay. Delete. I just go like pods dash all or something. What's the
Yeah, pod space dash dash all
dash
n istio-system. And this will eventually time out because we're going to lose our ingress into Open Unison.
Yeah, curious if there's something that maybe Marino installed that I didn't install, like in this transfers or something on my local machine that I'm missing.
No, my gut instinct is that because there are multiple Istio processes, something didn't get updated when all those objects got created. So those are all running again. So out of curiosity, try accessing our web service again.
Okay. What was that?
And try it in Brave. Yeah, I actually do want you to try it in Brave. Yeah, hit refresh.
Yeah. Nothing.
Yeah,
Same
it's
thing.
still... Yeah, it's that 404 that's the problem. Because that 404 means that it's not... that means that it's not... Istio is not routing to our web services or our web app. But it's weird because it works perfectly with Open Unison. All right, go back to Chrome. I'm just kind of curious. And then hit refresh. Or hit, clear out everything after the nip.io.
Peter, could you like check the chat?
All right, say again. You want me to check which chat?
Oh, the chat, like in StreamYard.
Okay, let's see here. So we've got a suggestion to check the virtual services.
And we do have a virtual service.
Yeah. Okay, where's that? That. Yeah. Okay. That's reasonable.
What I don't understand is why. So options. Yeah, the thing is, there's nothing really that special about the routing. We're just routing bait. What's weird is that in some instances the routing works, and in some instances doesn't.
So that's another suggestion. So if we do this dash O equals YAML, and then what's this namespace for this?
You want to do get VS.
Oh yeah. And then namespace is
-n is, I think, Istio-app.
oh, so they're both Istio app. Okay.
Yeah, I think so.
Let me make it bigger again. Oh no, it's app vs. There it is. That.
Yeah, so there's not a lot of there.
Mm-hmm.
So if we look at the app service, that's there.
Mm-hmm. Oh, special service.
Kind of wish we'd gotten Kiali up and running before now.
Yeah.
Might help us debug this. I know we're past the hour. I think this works locally for me. Let me just double check. I can always screen share. App.94. Log in. Double check everything works. Okay. So let me go ahead and show what it looks like.
Okay.
Can I share
my screen share then? Let me see here.
New window.
Stop sharing.
Big. Make this a little bit smaller.
But this has been a good way to just kind of dive into a few more of the specifics here of each of like the YAML configs and kind of how we trace this back of what piece connects to which. We looked at the virtual service here and how that connects back to Istio. Okay, cool. Now I can see your screen.
Yeah, so I'm going to go ahead. So this is the same thing. The only difference is this is running on a local cluster. So I go to log in. Now, you didn't see it, but I'm logged in to Istio. You can see I got my username and I got my my groups.
Do you want to like open up the like developer inspector portal?
Yeah, that's what I'm going to do. I'm trying to figure out how to put it back in. If I do this, no. How do I put it back in the dock? Oh, here we go. Like this. Okay, cool. Can you see it now?
Yeah, it's still, the text is still a little small, but yeah, not terrible.
This bigger.
Yeah.
And then I'm also going to do. Did I show the browser or did I show just the
tab? Sharing.
All right, I'm going to actually stop sharing. I want to share the entire window. Present. Share screen. And then I want to do a window. React app. There we go. All right. So I'm going to log in. Oh, I'm trying to log in. Is this? No, that's the shared one. Where's the actual?
I see your React app with the big login button and jwt.io tab.
Yeah, the problem is I don't see it. I can't
if you're on Mac, it must be on like a window to the side where you have to like full screen slide.
There we go. Okay. I think I'm good. All right. So I'm going to hit login. So lots of stuff just happened.
Yeah.
Okay. These URLs are all me authenticating. I called who am I. So this is where the response was my ID token. So this is the token I got from Open Unison.
Mm-hmm.
Big base 64.
Oh, that's so big.
Nope, almost too far. Right? Okay. So we were talking about jwt.io before. Let's go ahead and drop it in. Just a little bit bigger. All right. So I like to tie things together. This key ID, if we look back at the authentication request configuration we did for Istio, this key ID will line up with the key ID that was in that configuration. This issuer lines up with the issuer. The audience is my app. Mm-hmm. So we've got that. And then we've got our sub. Now, I'm also using Okta as an example here. it's an anti-pattern in the identity world to use an email address as user identifier. Names change for a lot of reasons. So Okta, Auth, most of the SaaS identity as a service solutions, by default your username is some random string. Google does the same thing. And then we got our groups claims. So if we come back here to our React app, that's the information that's being echoed back from the Who Am I service. So here we can actually see the same thing actually happened. It's just for some reason, even though it's the exact same code, just different host names, my Istio routed it. I don't know why. But it first ran this options request to see what would happen from a CORS perspective. Istio returned back that we would allow the authorization header. So that's where our authentication payload is. We'd allow both the get and options methods, and it can come from this app. So this URL lines up with what's running up here in the URL bar. Then it calls it again, this time with an actual get to be able to retrieve the payload. And we'll see that it actually has the authorization bearer. And this token is our ID token. Now, one thing I'll point out here is our expiration is at 11/06/25. So this token no longer works. If we drop this token into a curl command, it wouldn't work anymore because it's now expired. But if we come over here, we can see that every minute or so, React is refreshing our token. So we're getting a new token inside of React every minute, keeping our refresh token up to date. So that way, if anything between my app and my service leaks this token, we're okay.
Cool.
So if somebody else has this token, can they access this web application?
Until it expires, yeah.
Yeah.
So that's why it's so important to have that short-lived token. So like going back to what happened with Okta as an example, the Okta's problems all started because somebody entered a support ticket into Okta's system. It was Salesforce. That Okta ticket had an export of this trace from the developer tools, which included all the tokens. So nothing to do with this, but if somebody ever tells you, send me the browser trace, the answer is no. Like do a screen share or something, because this is everything, right? That's the downside of bearer tokens.
Yeah, and if that's living in like a email file attachment for years and years and years, right? Like you never know when it's going to get picked up by somebody.
Exactly. And like going back, we started our conversation in Kubernetes, before 1.21, 1.21 or 1.24? 24, I think, is when it became default. Kubernetes service accounts never had this expiration in there. So that, if you lost the service account, unless somebody deleted it from the API server, there was no expiration. So when people say don't use service accounts in your pipelines or anything that's talking to the API server, that's why. Because if you lost that service account, unless you deleted it, there was no other check in place to protect you.
And who really has that on like the checklist when someone goes away? And even if it is on the checklist, who actually goes in there and goes, all right, let me go find this thing that this one person had this one time and manually delete it? Like it's a thing that people just don't do.
Exactly. So we kind of went through that whole life cycle. Now, here's the fun part. So I'm logged in. I'm going to go ahead and go to KTOU.192. So I'm going to log into my Open Unison environment. And so this is me, and you can see the groups all line up, right? So I'm going to actually go to the dashboard. So that way I don't have to share this with anybody or with the tokens. So I'm going to open Unison. Don't worry about what's going on there because it doesn't really matter for us. But I'm going to go to custom resources. And then OIDC session. So Open Unison stores all of its sessions inside of the API server as an object by default. You can store it in a database too. And honestly, if you're doing application authorizations or API authorizations, you can't do that anyway. But you'll see that we have these session objects that are just a few seconds old. That's because every time we get a new token, we get a new session.
Got
So
it.
I'm gonna go ahead and
What
delete
is the, and so the end of that token lifespan, which is 1 minute, is the end of the session?
Right. Well, no, not exactly. So the session itself, and everything in here is encrypted, so there's not a lot you can do with it. But the session itself is based on this refresh token.
Gotcha. So not the 1 minute token I have, but the refresh token, which, what does that have, like a 30-minute lifespan or something?
Right. And you can see it expires in here at 1625 hours. So, 15 minutes is what this one's configured. It's all configurable inside of the YAML. But let's go back and we'll see that if I do a quick refresh here. So the last token was good about a minute ago. And just so that we have a marker for when the last one was posted. So about every minute, we're generating a new session. So I'm just going to go ahead and delete these. So now, if this goes the way I think it should, so these sessions are both old. So, okay, so I just missed it. So it actually did end up refreshing. So I'm just going to delete all of these. Now, we could do this much easier. We actually do have a label in here that has a base 64 encoded version of the user's DN. But I didn't want to deal with having to share my terminal.
And when you said DN, is that domain name? What is DN?
Distinguished name. So we maintain an LDAP virtual directory inside of OpenUS, and this is all transparent to you as the user. So there are no more sessions. In fact, I think I'm probably going to lose. Yep. I can't even access the dashboard anymore. I broke my dashboard access because I deleted my session. And then if we come here, there we go. The refresh failed because the session was deleted. And oops, failed to fetch. So now we've gone that kind of whole complete life cycle where we've logged in. We've retrieved our service, right? We had multiple layers of authorization. And then we've logged out, right? So, we're using we're using Istio here as an API gateway, right? Like we've gone beyond the simple. Oh, I stopped sharing. Here we go. We've gone beyond that simple use case or simpler use case. I don't want to say it's simple of using Istio as a service mesh. Now we're actually using it as a gateway to actually validate the requests coming in. We're authorizing based on requiring a JOT. We're authorizing based on CORS headers. We're authorizing based on the user. We didn't get into it here, but there's a rule that you can set to say, I want to make sure that you're a member of a group.
Right. So we're moving more and more into that like attribute-based access control where we can start to define more and more components of each session where we want to be like fine-grained into what do we expect when someone we trust is actually accessing the system.
Exactly. And then, where things really start to get interesting is Istio lets you have a webhook for authorization. So there are so the third edition of the book, the second edition, we just kind of glossed over and said, probably don't want to deal with that, probably more than you want to do. A lot has happened in the authorization industry in the last year. I think there are at least half a dozen companies now that are focused purely on authorization, doing all sorts of interesting stuff. Amazon released a authorization engine called Cedar, like cedar wood, that looks really interesting. For the third edition of the book, the Istio chapter, we're actually going to include Topaz, which is a combination of OPA and it's a combination of OPA and starts with a Z. Now I'm forgetting what it is. OPA and Zanzibar, Google Zanzibar.
Yeah, that's it.
So it uses OPA for defining the actual authorization engine, and then Zanzibar for defining the policies, or not the policies, the data that drives those policies. So probably the next time what we'll get into is like, okay, how do you populate that data, right? Like, how do you now manage who has access to what? Because you might use that as your authorization engine, but garbage in, garbage out. You need data to do that. And how do you manage that data?
Yeah, and I think we talked about this before, and like how do you securely like handle that data to where it's available at the time when you're running your policy enforcement, right? That policy enforcement point is now like, oh, you need access to the most current data, and you need to access it in a secure way in and of itself. And so, kind of like chicken or head chasing the tail situation, where it's just like, well, at what point do you give a little bit so that you know the whole process is secure, but you're still feeding fresh data in?
Exactly. So it really makes for it really ups the when you externalize your authorizations at an application level, which I mean historically up until very recently was almost impossible to do. Like people kept trying to do it and it never, like every time people tried to do it, they said no, this is too much. But now that there are so many options, I think you're going to start to see more centralization of authorization decisions in addition to authentication.
Yeah, that makes sense. And it is interesting because when the market kind of sees a need, right, then you end up seeing a bunch of companies pop up around that need. And so it's like seeing, now that there's 6 to 12 companies, just like in the CNCF alone, right, that are all trying to solve similar problems is kind of just showing that the market cares more and more about this authorization piece of the puzzle.
Yep. Yeah, nobody wants to maintain code that says if user is a member of this group, do this, and then log it in a consistent way. Like people want to be able to say, I want somebody else to make this decision, so that way it gets piped into the SIEM, and my security folks are happy, and it makes life easier for everybody.
Yeah, and long gone are the days where we just have a wiki that says these are our admins, and they all have the password.
I wish I could say that long gone were those days, but unfortunately, I think that's probably more prevalent than anybody of us want to
admit. Yeah. I mean, if you are doing it, you're definitely not telling anybody.
Yeah, exactly.
Cool. All right. Well, this is fun. Yeah. Let's start to wrap up here. Akansha, how did you feel about what we deployed? What did you learn? What would you like to talk about for this wrap up?
So, as I said, that I was not familiar with this domain before, but I used to be a React developer. So this token thing. So when somebody wasn't able to generate a token, we used to share tokens in order to access the application in order to work. So that is why I asked that question, is it possible? And that is such a bad practice, to be very honest.
Get the dagger out of my back.
Yeah, but I mean, everyone starts somewhere, and right.
Yeah.
Like I remember when I was learning how to code, and it was just like, well, if it's working over there, well, just send me all of your things, and then I'll try to replicate it. And it's kind of like, it's hard to start in the most secure place. Like you need to make the mistakes so that you can learn how to be better in the future. So that's cool.
Yeah, absolutely.
Look back though and recognize that.
Yeah, but yeah, this was really fun. A lot of things to learn about, and just hoping for a next great stream that we do.
I think next time we're going to do Kiali. And with this broken, it might make it easier to see what's going on
Oh yeah, I think so. I think that'll make it fun, right? Having a little bit more of those like visualization tools for us to like dive into the network components and how things are actually connecting. I think that'll be a great way for us to really like communicate what we're thinking about in our head as we're trying to trace through these problems. Cool. All right,
Yeah,
that sounds
definitely.
good. And that'll give everyone something to look forward to.
Yeah.
Yep.
All right.
Awesome.
All right, let's double check. Yeah, okay. So I think we're good. We can wrap up here a few minutes early and yeah, call it a day.
Awesome. Thanks, everybody.
All right.
See you next time.
Thank you, Kasia. Yeah. See you guys next time. And thanks
Bye.
everyone who joined the stream.